Good morning. Hi, everybody. Welcome to our third lecture, DSCI 513. In this lecture, we'll learn about aggregation functions, grouping, and joins. And the last topic of today, joins, is something that we touched on briefly in DSCI 511. I guess you also discussed this in DSCI 523. But today, we're going to be learning about joins in the context of SQL. And joins are actually what make relational databases efficient, and this is what we're going to be learning about today. Okay. Let's get started. So, do our usual stuff here, importing our password, connecting to our database. Now let's get started with aggregations. So in the last lecture, we've learned about a couple of functions that do different things. For example, the rounding function, the square root function, extracting pieces of date times from rows, from columns, and stuff like that. We've learned about all of that. In this lecture, we have these specific type of functions called aggregation functions. What they do is that they do some particular operation on a bunch of rows instead of doing operations on just one row. So, for example, you remember that when we applied this round function on numbers, it would round each and every number in a particular column to a specific precision. However, we have a bunch of functions here. One of them, you are already familiar with one of them, count, which is applied on a bunch of rows instead of just a single row. Basically, these functions are also called summarizing functions as well because they summarize the information inside a bundle of rows. In SQL, we have count, we have min, max, AVG, and sum. These are the kind of all of the aggregation functions that we have in SQL. So you can see that they're not too many. And this goes back to the reason that we discussed earlier that SQL is not a language or an interface to do data analysis. It's designed for efficient data retrieval and data storage. This is why we only have this many aggregation functions. We have a couple of others too. We will learn about them in lecture 6. But this is basically the main ones. So just very basic stuff. Counting, min, max, average, and sum. Okay. So I guess, the meaning of minimum, maximum, average, and sum are pretty obvious. There is just this count function which counts the number of rows in a table. If you do count star, it will count all of the rows, and you don't need to specify a particular column. However, if you specify a particular column, it will give you the number of non-null values. Okay? So that's one very important thing about the count function. Other than that, here I have a note that min and max will work with numbers as well as with strings. That's all there is to these functions. So let's move on and see how we can apply them in our queries. Okay, so this question, find the population of the world according to the country table in the world database. So you've done a number of such You've written a number of such queries in the lab using pandas functions. However, in this lecture, we learn how to do them purely in SQL. So, in this case, the syntax that we have looks something like this. Select, and instead of just having population there, we want to sum population over the entire column population. So basically, take the sum. And when we do that, you run it, and that gives us the value, summing population over all rows. And we can do the same thing with min, with max, with average, and with count. All right. Now comes the stuff that's actually very important in how we apply aggregation functions in our SQL queries. So we have another query here. Okay, select average life expectancy along with the sum of population. from the country table where continent equals North America. So the average life expectancy and the total population for North America. This is fine. However, when we apply aggregation functions, we have to be careful that we cannot have an aggregated column, like this one over here, and a non-aggregated column together. So average life expectancy and the name of the country. And can you tell me a logical issue with that query? Yes? Yes, that's right. That's right. Anything more, like kind of more obvious? But that's right. I mean, yeah. Not exactly. Okay, if you think about how this operation works, so it looks at all of the rows for life expectancy, takes the average, and we want also to list the name there, the name of the country. Yes?
If you're, for example, here you're limited to all countries in North America and getting their life expectancy, the name doesn't make sense because it won't be a North American country and not particularly one country.
Exactly. Exactly, that's the issue. So, I mean, actually the where clause doesn't play a role here if you even don't have that. The issue is that you do that averaging thing over several countries, and you cannot really name just one country there, right? Because the average returns one value to you, and you have to put one name there. Which name would you put there? It's associated with a bunch of rows, not just one single value, right? That's the problem, and this is why this query actually doesn't make any logical sense. Okay. Yes?
So basically, you're saying we cannot make calculations based on a single row of data, right?
Calculations with a single row of...
Do average, do sum, do mean or max with one single row.
Right. That's true. We cannot do computations that involves one single row, basically, because, again, aggregating means you're doing something collectively on a bunch of rows. So there is no one row, no one value associated with any one of them. Yes. Yeah, so you can see that this makes sense, that this is wrong and not possible, and this actually throws an error if you do that. The only exception to this is when we use a clause called group by, but we will learn about that in a bit. For now, just remember that we cannot have an aggregated and non-aggregated column together in a query. All right. Now, and this query is also something that would give you an error. So select name from country where population of that particular country is greater than the average population. This would throw an error. And why do you think this one throws an error? It relates to what we have learned in lecture 2. Okay, so in lecture 2 we discussed, yes? Pardon me? That's right. It relates to the sequence of execution or processing of different clauses in SQL. And when you execute, so the from clause would be processed first, okay, pulling data from a table. And then we have the where clause. At that point, this average function cannot be evaluated because it relates to somewhere in the select clause. It doesn't belong there. It cannot access, it cannot do a processing like that in the where clause yet. So I've shown you, let me actually bring that node up. So here, we had a diagram over here. Oh, yeah. Okay, so we started from this from clause and then where clause, and then we had the group by clause and select clause, and the averaging function actually belongs to the group clause, not group by clause, not the select clause. But this is why, because of the order of processing, we cannot compute whatever belongs to here, this area, in the where clause. Okay, So this is pretty important, and this comes up a lot. And if you just remember that diagram and the meaning of it, that the from clause executed first, then the where clause, then group by, and then select, and then finally order by and limits, that will answer a ton of questions that you might have about specific rules that we discuss here, which are too many to memorize. Okay. So just for now, let's just remember that this is not possible because we cannot have aggregating functions inside of the where clause. Questions about this? Okay. Now, something just optional, just as an FYI, Postgres has a number of its own specific aggregation functions to compute standard deviation, regression coefficients, and stuff like that. And these are just helper functions. These are by no means from SQL standard or something for you to do, to use SQL to do analysis. Just for you there as a helper, if you absolutely need to, you can use those. But you can just ignore that. Okay. So here I have an example. Compute the average plus sample standard deviation of the population of cities in the US using the city table. And then, yeah, pretty straightforward, I guess. We have the where clause limiting the country, and then we're pulling data from the city table. The only thing that we're doing here is that we apply this aggregation function on the population column, and then we use this Postgres function to compute the standard deviation, converting both to integers and finally concatenating them with a string. Nothing really too complex, just applying aggregating functions, and that's it. All right. Now, let's talk about grouping, something that we have been implicitly doing, but we haven't mentioned it. Okay, so grouping refers to kind of processing when we work on tabular data where we divide the table into several subtables based on the rows, and then we do some kind of operation on each subtable, on each bundle of rows, basically. So in the previous section that we just covered, we applied the average function, for example, or the sum function on the entire table. Just imagine that we do the same thing. Instead of applying it on the entire table, we apply that on specific subtables. Okay, this is what grouping means. I guess that would be much more understandable if we just show you an example. But before that, let's just take a look at the syntax here. So we have select, and then we have aggregated columns, just like we learned. And now we learned that the only other thing that we can have in the select clause, apart from aggregated columns, are columns that appear in the group by statement here, in the group by clause. Okay. And this is the syntactic order of the clauses: select and some grouping columns from a particular table. And note that this group by follows the where clause. This is very important. You cannot write it in any other way. But now let's see an example. Suppose that we want to find the average population of countries in each continent. Okay, so this is different from the queries that we have learned so far because it requires some initial step of processing. We first have to look at the entire table, find all countries that happen to be located in the same continent, and then apply the average function on those group of rows. And then go to the next group, find all of the countries that happen to be in another continent, apply the aggregating function on that, and so on and so forth. So basically, we take groups of countries belonging to different continents and apply the aggregating functions only on those groups. This is how we write the syntax. So select, we have the continent, we have the average population, and then here we have the group by clause. So we're telling SQL, hey, I want you to group the rows by the values that exist in the continent column. So we have a bunch of rows that have Asia as the continent. We have a bunch of rows that have Europe as the continent, for example. We want to consider those rows together and then apply aggregating functions on those rows separately. And in this case, now we have continents, a non-aggregated column, and we have average population, an aggregated column. But in this case, it makes logical sense because if I'm computing the average population for countries in Europe, then it makes sense to have the continent name in the select clause. Because you say Europe, this is the average population. Asia, this is the average population. Africa, this is the average population. It makes logical sense. There's no ambiguity. Okay, let's see. So now this is exactly what we needed and what we expected. So for each of these countries, you get the population, the average population of the countries that are located in that continent. Yes. If we didn't have group by, let's just run that. We would have this error. It says that column country continent must appear in the group by clause or be used in an aggregate function. All right. Okay, so this note just relates to the fact that we need to respect the order in which different clauses appear in the syntax. Okay, we discussed that. And then we also discussed this one. One important thing about group by function, the group by clause, is that if you have null values in the grouping column, there will be a separate group just for the null values. Okay. So let's consider this query. Write a query to return the average and maximum population of cities in the city table for these countries, and then show the results for each country using the corresponding country code and order groups alphabetically in ascending order. Okay. Okay, so in this case, we have to kind of know, so we can take a look at the city table to see what's going on. Select star from city, and let's just limit that to 10. And then this is the city table, so it contains the name of the city, the country code, and the population are the most important columns here. Okay, and what we need to do in this case is we want to return the average and maximum population for these countries. So information about the countries is stored inside of the country code, so we need to know the country codes for these ones: China, India, Canada, US, Australia, and Russia. And then the other ones are just a bunch of specifications for our query. Okay, so in this case, we need to group by country code because all of the cities happening to be in a country have the same country code. So we just do the group by on that column, which is what we do here. Okay, this is just stating that I want to consider only these countries with these particular codes. And then apart from that, we just apply the average and max on the population column. So the most important thing here is that we're grouping by country code in order to look at the cities located in each particular country. And when we do that, you can see the country codes, average and max population. Okay, let's have that on the screen here. Okay, so we are able to list the country code because it also appears in the group by clause. Otherwise, it would just throw an error. All right, any questions? Okay. Okay, so far we have learned how to filter rows based on particular conditions that we want using the where clause. Now we might have a situation where we do some group by and we apply some aggregated function, and then after that stage we want to filter the results. In that case, we can use the having clause, and having is used to filter rows that result from the grouping operation. So suppose that we have this thing resulting from this group by operation. So, for example, the average population of cities in these countries. If we now want to filter the results, we cannot do that with where. We should do that with this particular clause, having. Okay? All right. This is the syntax. So the having clause follows the group by clause, like this. And the way that we write a condition for the having clause is pretty similar to what we do with the where condition. Let's take a look at an example here. So write a query to return the average and maximum population of cities for countries. Here goes the condition, that have at least 60 cities listed in the city table. Okay, so this is a condition that we can't really do anything about before doing the grouping, right? We have to do the group by, and then we have to count, and then it's only then that we have access to that information for which we have a condition here, right? Because before doing the group by, you don't know how many cities exist in each country, right? So we have to do that first, and then we have to apply a having clause. You can't do such a thing using the where clause. Does that make sense? Okay. All right, so it's, again, pretty similar to the previous query. The only difference is that we have a condition that we want to apply on the aggregated values. So this should be something now. Let me change this to integer and int over here as well. Okay, average, pretty usual stuff now. Average, maximum, count. Okay, nothing to be concerned about. Now you can see that we're doing the group by country code, similar to the previous query. The difference is that now we are applying a condition on aggregated values. So we say that only return those rows to us for which we have a count greater than 60. Okay. Now if we run that, you can see all of these city counts are greater than 60, right? And this is a result that we couldn't have obtained if we were limited to just using the where clause, right? Questions about this? Yes?
Last week we learned that you can make a new column using select. You can't filter it using where because where happens before select.
Right.
Can we use having to filter those columns from where to select?
Can we use having to filter those columns that we have in select?
Yeah, so just having before after select.
No, actually, I can go back to the diagram that we had, and it also contains, it contains having as well. Having occurs right before select. So again, we are in the same situation, basically. Yep. Okay, let's go back here. Okay, any other questions about having, about group by, aggregations? Okay, all right. Let's move on. So again, coming back to this point, where is used to filter rows before grouping, and having filters rows after grouping. Okay. All right. One other thing about the group by clause is that we can sometimes we can use it instead of using distinct. And for example, we have this particular query here. We want to find the unique values stored in the continent table. Basically, we just want to look at what continents we have in that column. And if we do group by continent, it gives back to us the continents. This is something that we could have done using distinct applied here, right? Something like that, and then remove this, and then this would give the same result. So we can use group by because group by gets rid of all of the duplicate values in a particular column. So we can use it instead of distinct, if you want to. Okay, let's put this back. Yeah, we have that here as well. Okay. So again, neither group by nor distinct, ignore null values. We will have a particular row just for the null values if we happen to have them in our table. Okay. So here, because in the head of state column we have null values, and I'm grouping by the head of state, we see that right at the top we see this none, which is Jupyter Notebook's way of saying that this is a null value. So you can see that it has its own group, basically. Something worth noting, I guess. Okay. One other thing, actually a question that came up quite frequently in the lab was that if we have a bunch of, like 1, 2 columns in the select clause, but then we want to do something with another column that doesn't exist in the select clause, we want to use it in the where clause or in the order by. Is that possible, or why is that possible? Again, it goes back to the sequence of processing. So even if we don't list a column here in the select clause, we will still have access to all of the columns in our table. We can use them in the group by, we can use them in the having, we can use them in the where. Because SQL only looks at the select clause at the very end. So regardless of whether you have it in the select clause or not, you have access to all of the columns, so you can use them wherever you like. So here, I'm selecting a continent column, but I know that that's something that SQL looks at last. And then I'm grouping by continent, and then in my having, I have this name column, which doesn't exist here, but it's fine because select is going to be processed after having. All right. Yeah, so this question basically just relates to what we discussed. Everything goes back to the order of processing. Okay, all questions of this kind, the reason is because of the particular way that SQL executes clauses in a query. All right, questions about these? Anything? Yes.
What's name in this context?
Oh, name. Yeah. Sorry about the highlighting. It's not actually a keyword or something. It's a column inside of the country table. It's the name of the country. Yeah. So one of the columns, just like continent, name, population. No. Okay. So grouping is not limited to just one column. We can actually do group by on multiple column values. And what it does is, instead of looking at just one value, it looks at, for example, here in the values, looks at the values in 2 columns and groups rows for which we have similar values in all of those columns. So here, I want to do the group by continent and region, meaning that I want to bundle together all of the rows that have the same continent and region values. And if we do that, we can see that here we have Africa and then the region Central Africa. And this average is done for all of the countries happening to be in this region and in this continent. And same goes for this region, this continent, this region, this continent. So the average is done over all of the group of rows which have similar values in both of those columns. So look at the syntax again. We're not just limited to one column. We can list multiple columns there. Okay. Great. Okay, so that's it about aggregation functions, about group by, and also the having clause. So before moving on to joins, any lingering questions? Yes. Yes, combinations. It looks at, yeah, you have to have the same values in both columns, basically. Scroll up or down. Okay, so can you speak up? Yes, yes. So what it has done is that it has grouped, for example, all of the countries that are in Central Africa and in the continent of Africa, grouped them together, applied that average function, and that's the value that we end up with. And then it looked at Africa and Eastern Africa, let's say if there are 5 countries, and then compressed all of those down to this one number. Yeah. Okay. All right, so now let's move on to joins, and Tara, let's talk about them, talk about these kinds of operations for 5 minutes maybe, and then go on a break. So joins are probably the most fundamental operation in relational databases. So previously we touched on joins in pandas, and we talked about them maybe for 5-10 minutes. It was just about merging 2 tables in a particular way. But in relational databases, this is like basically the whole idea. We have the data split in several tables, and we rely on joins in order to merge them back together to basically retrieve data that are related between multiple tables. So joins are, in my opinion, the most important operation that we learn about in this course, about SQL. Okay, so just to remind ourselves what we need, why we need to split data apart in multiple tables, let's just refresh our memory. Why did we do that? So again, going back to the example of having data about instructors, about courses, and so on and so forth. What would be wrong if we store everything inside one table and just get rid of joins, basically? There will be a lot of duplication, so we would have an issue of redundancy. Right, exactly. So there is also a performance issue, because if we have everything in just one table, once we retrieve data, we might not want to retrieve everything from that particular table. And it has also some I guess, a logical problem too. So the table does not any longer belong to an entity like an instructor or a course. It will just be a bunch of data related together. So you can have an instructor, the courses that they teach, addresses that they have saved in that database, emails, their salaries, the financial, other financial information, like everything, department information. So it's everything in just one place. It doesn't really belong to any one of these entities. It could be considered to belong to like courses, to departments, depending on which columns you look at. So it's a pretty messy way of storing data. Okay, what else?
Also, the issue with updating the data in the database as well.
Sure, yeah. That's, I guess that's again goes back to performance redundancy issue. Yeah, what else did we discuss, if you remember? If we have everything in just one table, apart from performance issues, redundancy. So the thing is, in SQL, we are able to give different kinds of access privileges on different tables, but we cannot do that based on columns. So we cannot give one person access to specific columns and another person access to other columns. Okay, so this is again another thing, the issue of security. So we want to split data into multiple tables so as to be able to give access, for different people, we give access to different tables in a different way. So I can access, for example, the instructor table, but not necessarily the home address tables, for example, or the financial table information. So this is another issue that we might end up with. Okay, so this is all to say that we need to split data apart into multiple tables and then join them together. And this is why we study these joins. All right, so write a query that returns the name of all countries along with their corresponding continents and their cities. So if you think about this query, name of countries, corresponding continents, that's fine. They both happen to be in the same table. But cities, they're located in another table, right? We have a country table, we have a city table, we have a country language table. Okay, so in this case, because the data is in different tables, we have to join the two tables together in order to be able to retrieve that data. So let's learn about the syntax of a join. We have learned about all of this part here, where, group by, having, order by, but this part is new. So right after the from clause, where we specify the table from which we want to pull the data, we have this join type, and I will tell you what kind of keywords we can use there. And then we have an on clause, meaning that we want to do the join based on common values in particular columns. Okay, so just an overview of the syntax. Let's move on. And here, instead of working on joins in the world database, I'll create a sample small database called MDS that just stores information about instructors in MDS. So it seems like, yeah, this already exists because I have already run this code. And then you don't need to worry about this code here. It just creates the table and populates it with data. We will learn about how this code works in the next lecture. For now, you just run that, and it creates those tables and adds those values. The important thing is that we now have a table called instructor, containing information about different instructors, and then we have a table called instructor course, containing information about different courses and the IDs of those instructors who teach those courses. Okay, so basically these two tables. All right, so before talking about further about joins, let's take a break for 5 minutes, and then we'll be back in 8:43. All right, we're back. Okay, so I just remembered one important thing to tell you, something that if it comes up, I want you to know why it happens. So just before working further on the joins, take a look at the country table. We have these columns: code, name, continent, region, and so on. Now take a look. So code and name are two columns basically in that table. Now take a look at this code. Would this code work? Yeah. Okay. Yeah, sure. Yeah, but it works. Okay. It's not really helpful, but it works. Okay. How about this one? It wouldn't work, right? Okay. You're right. In SQL standard, that's true. It wouldn't work because we don't have name in the group by clause. But if in the lab or somewhere else you run a query like this and surprisingly it works, it's because of the particular trick that Postgres does, and that's when there is functional one-to-one functional dependence between two columns, then a query like this would be possible because there is no ambiguity in what value to list for name. So for each country code, you have a specific country name. So there is no ambiguity. So when you group by code, it's just as if you have grouped by name. So there is no difference. This column name is functionally dependent on the column code. This is something related to Postgres, and it has been like this since Postgres version 9, and something just helpful or useful for you to be aware of. Okay. All right, remember that this particular thing works if you group by the column that has a constraint of uniqueness, otherwise it won't work. So for name, we don't have such a constraint. And if we do this, it still complains. We will learn about this particular constraint in the next lecture. But for now, just know that for something like this will work. All right, let's now go back to our joins. Okay, we have created our tables, and then, so these are the tables that we have: instructors, instructor courses. And now let's learn about the simplest type of join possible. But before that, let me actually connect to this one again. Yeah. Okay. Okay, so the simplest type of join is called a cross join, and that's when we basically don't care about the values in the columns of the two tables. We just pick each column from one table, and we pair that up with each and every, we pick one row of one table, and we pair that up with each and every other row in the other table. Okay, so we don't care about column values. So the way that we can write this in SQL is something like this. For example, select all columns from table instructor and then cross-join instructor course on that. And that's all there is to it in terms of its syntax, because there is no condition, there is no on clause. And in this case, we had 16 rows here and 11 rows here. So what do you think, how many rows do you think the output will have in this case? 11 and 16? Yeah, 176, and it says, 176, and it's basically just blindly matching the rows together, okay, pairing the rows together. Okay, so everything with everything. Okay, so that's a cross join. All right, so we don't really talk much more about cross join, just for you to know that this is the simplest type of join. Now, something pretty important that comes up when you deal with joins is that sometimes you have the same column names in two tables. Oh, yes, question.
Quick question. When would cross joins be useful?
Yeah, there was a time that basically other types of join would first do a cross join and then filter the results based on what we wanted. That's no longer the case because we have special keywords for that. There are other, not off the top of my head, I can't think of any other applications now, but I'm sure maybe you can find some edge cases perhaps. Yeah. Okay. So suppose that we want to join two tables together, and then both of these tables have, for example, a column called ID. And in that case, there would be ambiguity as to which columns we want to retrieve the values from. So you can see something like this here. If I remove this, we have the ID column both in the instructor table and in the instructor course table. So if I have ID and ID, it doesn't know which table to pull data from. So in that case, we do something that we learned about in the previous lecture, and that's giving aliases or labels to, in the previous lecture we gave labels to columns, here we gave labels to tables. So here we can say, okay, give in the instructor table this alias, and then instructor course table this alias, so I and IC. And now I can prepend the column names with the aliases so that there is no ambiguity. Okay, so we know that ID there refers to the ID column in instructor table, and ID here refers to the ID column in the instructor course table. Okay, so you're going to use this a lot because usually the name of the tables are a bit long, and we don't want to repeat the name of the tables like that. So you can also do this and that. Okay, but this makes the query too verbose, I guess. So we prefer to use the aliases like that. Okay. Now if we do this cross join, it works as similar to before. And note that here, instead of selecting all columns, I've selected the name column. Notice that this name column is not ambiguous, so I don't need to prepend it with the table alias. But for ID, I had to do this. Course, unambiguous. Okay, no need to prepend it with the alias. And then this one. And this is the result, similar to what we had before. So just a cross join, simple case of just pairing each and every row from one table to each and every row in another table. All right. And one other thing to further make the query maybe shorter is that we can get rid of these as keywords and just write it like this. It will still work. Okay, so instructor I, instructor course IC. And the queries that we see here in the lecture notes are relatively short. However, real-life queries tend to be much longer than this, usually maybe they span several lines, and in those cases you have multiple tables, you have joining several tables together. In a database, it's not unusual to have 100, 200 tables. So in that case, you'll probably be joining a lot of tables together, and it's very helpful to be able to give aliases to tables like that. Okay. Note that this table aliases that we set, it's not a name, a persistent name that we give to our tables. So as soon as the query is done, this alias doesn't exist anymore. So all of these aliases that we give to columns or to the tables, they only persist during the execution of a query. As soon as there is this semicolon character, then everything is gone. Okay. So one other note is that as soon as we create an alias for a table, we have to use that alias when we want to prepend a column with that. So here we have given this alias I to table instructor, and then we are still using the original table's name. So we can't do this. This is wrong. We have to use I now that we have given it a new name. Okay, one other thing, to retrieve all of the columns from one table, but specific columns from another table, we can still use the star notation. So instructor.star means that retrieve all of the columns from instructor table, and then only the course column from instructor course table. Okay, any questions about table aliases or anything else up to this point?
Question for
Yeah.
at the bottom, since we have alias for the instructor table, should we use I dot star slash?
Yes. Yeah, okay, maybe that, yeah, okay. Good point, yeah, this is that should be I, that's correct. Okay, yeah, good point, thank you. Okay, now let's move on. Now comes the more important type of join called an inner join. So far, cross-join was just blindly matching rows together. However, usually we want to do the join based on values in particular columns. For example, if we want to retrieve the cities and country names using the two tables that we had, we want to first look at the values in the country code in order to see which cities belong to which country, and then only match those particular cities to each country in the country table. So we don't want to match every city with each country, right? That doesn't make any sense. We want to retrieve, for example, for Canada, we want to pair Vancouver, Montreal, Toronto, and so on with the country Canada. That's what we want to do with the join. So in this case, we use an inner join to use a condition called the on clause in order to specify that we're looking for equality between a specific column. The important thing about an inner join is that if there isn't a match between two values in two columns, then those rows will be discarded from both of the tables. Okay? So if there are two rows, the values in the column that we're looking at don't match each other, then the rows will be discarded. So we are only retrieving the common column values, only the rows that have common column values. That's the meaning of an inner join. Okay. So for example, in our instructor table, there are some instructors who are assigned one or more courses in the instructor table, and some who are not. And also there are, in the instructor course table, some courses have an instructor, some courses don't. So if we do an inner join on those two tables, instructor and instructor course, and notice the inner join keyword here, and we have this on clause based on equality between the ID of instructors between the two tables, then if we run this query, we will have a result like this. So this is, you can see that the IDs are matching because of this condition. The IDs are matching, and we have basically picked the course from the right-hand table and matched it with the instructor from left-hand table. And we get duplicates, as many duplicates as needed. So Alexei had only one row in the instructor table, but because, for example, he teaches two courses, that row is duplicated in order to accommodate that, right? So Alexei, statistical inference, Alexei, and regression 2. Okay, so those we will have, usually what happens with joins is that we get duplicates. Okay. Again, same goes for other instructors, and these are only those instructors and those instructors who teach a course and those courses who have an instructor. Okay. There are other courses and other instructors that might not have a course or might not have an instructor. So that's the meaning of an inner join. Let me show you the syntax again. Note that this word inner is optional. You can just omit that and it still works in the same way. Okay, and I include that only for readability. Okay. So, questions about an inner join? Okay. If we do an inner join on the same table, that would be called a self-join. There's not like too many situations in which you join a table onto itself, but still something useful in particular situations. So here, the only difference is that instead of joining another table onto instructor table, I'm joining itself. I'm joining instructor table on itself. So you might be asking, where would something like this be needed, or what's the application? For example, if you want to know which pairs of instructors in the instructor table are from the same department, that's a question that we can answer by using a self-join. What we do is that we join the same table onto itself, and then we're looking for rows for which we have equal values in the department column. Okay. So in that case, the result would look something like this. So you can see that departments match between these entries. So Mike and Jessica, Mike and Varada and Jessica, you can see that those people in the instructor table happen to be in the same department. This is a situation that a self-join might work, and the whole idea is that we do the join using one table instead of several tables or two tables. Okay, questions? Yes. The question is about the as keyword. Yeah, it's too hard to hear. Okay, so can you repeat your question? Sorry. Right. Yeah, so the as keyword is optional. You can have it in there for readability, but usually what you see in queries written by most people, they just ignore those as. Yeah, it's something like the inner keyword, or yeah. Okay, so that's optional. The as keyword is optional. We can also have it in here, but you don't necessarily need to have that. Okay. So this was self-join, and note that I have this condition here in order to avoid a situation like this happening. So Mike and Mike, for example, or Tiffany and Tiffany. So I say that I also want this condition to be true to avoid rows do not match themselves. Okay. Another type of join is called a natural join. Again, we're learning about these not because these are examples of joins that you would use a lot, but something that happens is that when you look at queries written by other people, it's quite common that you see like these different keywords, and you might not know, okay, what is a natural join? Why is this person using the same table and joining it on itself? So it would be useful for you to know what all this is about. But usually what we care most about is the inner join and also outer joins that will follow this section. So a natural join, it's really just a syntactic shortcut to say that we want to join two tables together with the on condition written on all similarly named columns. And we call that a natural join. If people who design the tables design them in a way that columns on which we usually do the join have the same names, we don't have to write all those on clauses. We just do select this one and from this table and just natural join that. And then it looks at those two tables, and then it looks for similar column names and does the join on those columns. This is called a natural join. Okay, so for example, here, let me actually show you the course cohort table. So you can see that we have a course ID, and we also had a column ID in the table instructor course. And because those two columns have the same names, it just uses those columns in order for the join. Yeah.
What happens if two tables have two similarly named columns? Does it do like that?
Okay, so this is the situation that we're looking at, right? So one table has a column ID, the other also has a column called ID. And then when we do natural join, it matches those two columns together.
What I meant is like if each table has ID and cohort,
So one table, I mean, both tables have two similarly named columns. So, okay, yeah, that's a good question. In natural join, it actually uses both of those columns in order for the joining to happen. So it uses the equality on both of those. It would be similar to writing the on clause and saying that, hey, match this column with this one and match this column with this one. Yeah. Yeah. Yes.
So this is just for demonstration purpose,
Right.
Just for natural join and the structure table and the forward table based on the ID.
That's true. Yeah.
It doesn't really make sense.
Absolutely, yeah. These are just super small tables, and I've only created these in order for the data to be understandable when I show this in the lecture. You're right. In this case, it really doesn't make much sense to use these. Yeah. Okay. So that's a natural join. And then one last point about natural join is that if there are no matching columns in the two tables, then it will act like join on true, meaning that it will match each and it will results in a cross product between the participating tables. Okay, not too important, but something for you to be aware of. Now, outer joins is also something that we discussed in Pandas just very briefly. But outer joins basically pertain to the case where we have non-matching columns in one or both of the tables. So with an inner join, we only listed the matching rows, right? With an outer join, we are able to list not only the matching, but also the non-matching rows. And we will see why this might be helpful. So with a left outer join, we return the rows with matching column values, and also all of the rows from the left-hand side table. So everything from the left-hand side table and only the matching rows from the right-hand side table. This is called the left outer join. And the same is true as something similar, I mean symmetrically true, is a right outer join, which includes everything from the right-hand side table, matching or non-matching, and only the common rows from the left-hand side table. So these are just symmetric cases. And with the left outer join, okay, let's consider this query. We are selecting these columns, not too important. We are pulling data from this table, and then we're left outer joining this instructor course. And this is now different from the previous case in that here, now we have courses for which, we have instructors in our results that do not teach any courses. And that's actually the meaning of a left join. Because we're joining, this is the left table, so we're returning everything in the left table. So these instructors don't teach a course. We're still returning them because this is a left join, and we're returning everything from the left-hand side table. And the first one that appears is the left-hand side table. Okay, and you can see that here, we're only returning the name of the rows for courses for which we have matching values in those instructor ID column. Okay, how can this be helpful? Why would we need something like this? So think about this query. How can we return the name of instructors who don't teach any courses using a query? So take a look at this and tell me how could that happen. So we want to retrieve the name of instructors who don't teach a course. Or maybe we want to count them. Then we... Right, exactly. So we can do the same thing, and then after the join clause here, we can add a where condition saying that, okay, now show me the rows in the results that have null values for the courses. Then in that case, it will look something like this, and this will return only the name of the instructors who do not teach a course. And this will be pretty helpful in counting, for example, how many instructors do not teach a course. Okay, so the where clause and is null is something that's used commonly in joins to figure out what are the non-matching rows. Okay. And notice that the outer keyword is optional. We can just omit that. All right, so same goes for right outer join, and I'm not going to talk too much about that. Just run the query, And now this is the other situation. We still get the matching rows. However, this time, we retrieve courses for which we don't have any instructors. So everything from the right table is returned to us, meaning that all the courses would be returned to us, but not all instructors. Only instructors who are assigned a course. That's the meaning of a right join. Okay. Any questions? So similar to the above query, we can run something like this with the where condition to find the courses that do not have an instructor assigned. Okay, so lastly, we have full outer join, which is a combination of the left and right-hand join. So everything matching and everything from the left-hand side table and the right-hand side table. So basically just a combination between a left join and a right join. If we do full outer join here, what we get back is again all of the matching rows and all of the rows in the instructor table in the right-hand side table, and all of the values in the courses table, and all of the values here in the instructor table. So you can see a bunch of null values appear when we do a join like this kind. Okay, so everything from both tables and also the matching values. All right, and this is the syntax. Okay. So now if we want to write a query to find instructors who are free to teach a course and courses that need an instructor, we can write something like that. And the only thing that we add is that we want to find whether instructor name is null or course name is null. And then we find these ones. These instructors are free. These courses do not have an instructor. All right, now one question here. What's the difference between a cross join and a full outer join? Are they the same? Yes. Exactly, so the full outer join still combines the matching rows. And for the non-matching values, it only lists those rows. It doesn't pair that up with each and every row in the other table. There's a big difference between a cross join, which is just a blind join, and a full outer join, which still pairs the matching rows and brings everything from the right-hand table and the left-hand table. Okay, so as far as the required material goes, we have covered everything. So since we have time, let me just quickly tell you something about where joins. And this is because you might still see queries like this written, and I want you to know what this is about. So before SQL 92 standard, there was no join or cross join or left join for joining tables in SQL. And the way that people would do it is that joins were used by pulling data from multiple tables directly in the from clause here, like from table 1, from table 2. Okay, and this would give you a cross join between the two tables, and then you would write a condition in order to filter that cross joined result for the particular rows that you're interested in. So this was how joins worked in the past, but this is no longer the case. This still works, but we have these specific keywords for joining. And the other thing is that we didn't have a way for writing outer joins, actually. And yeah, this was just something that people had to deal with. So for example, this is an example of an inner join. So select table columns here, table 2 columns here from these two tables, and then using the where clause, we would match the rows that have common values between these two columns and then filter them, basically. So if we apply something like this on the instructor course, just to show you that it actually does a cross join. You can see 176 rows affected here. And the from clause, unlike all of the from clause that we have written so far, contains two tables, not just one. So this gives a cross join, and now we can go ahead and filter these results based on what we want. For example, we can do this to return instructors and courses. So we do everything without using the join keyword, but we just simply do a cross join and then filter the results. This is what's called a where join. In case you see that somewhere, you see multiple tables in the from clause, this is what it's about. Okay. And here is a note saying that in this older syntax, we didn't have a way to do an outer join, and there was specific syntax for each RDBMS in order to implement that feature. There was no standard around that. All right, so that's it for this lecture. We have a few more minutes. If you have questions, I'd be happy to help you with those. Yeah. Yeah.
Can we understand that a working standard for using that is we have two tables and they're different, and we want to make them at one bigger.
Right. So is that an application of a cross join? You mean that? So yeah, could be. I mean, sometimes it is helpful to pair everything from one table up with everything else from another table. It could be useful. I mean, I just didn't remember a particular example. Yeah, sure. Yeah. That's exactly right. A cross join is a cross. They say cross product or Cartesian product, I guess. Yeah. It's the same thing. Yeah, so in set theory, we have this concept of Cartesian product that takes and pairing everything from one set with another set. Yeah, that's right. Any other questions? All right. All right, so that's it for today's lecture. Have a good rest of your day, everybody. Thank you.